Hello everyone, this is the screencast for DevOps Milestone 3. In this milestone, we are working on automatically deployment. We will provide a continuous deployment pipeline, which are doing the following 6 tasks. So this is the architecture of our pipeline. We have one master server and several slaves. In the master server, we have Jenkins running on it, and we have Redis. We also have a feature flag selector. We have a load balancer, and we also have a monitoring and one scaling script. In each slave, it has one monitoring script, which will continuous reading the operating system performance metrics from the system, like CPU and memory overload. Let's have a look at the first task. The first task is automatically deploy the production environment in a remote machine. Like here we use AWS. This is the simple application we use to deploy in each slave. So you can see here, this is our application.
Yes, this is the current application. As you can see, we'll try to change the content on the page, and it will automatically deploy after the tests are passing. So yeah, let's change some content.
Congrats to Donald Trump.
Then we try to add this file, commit this change, and push this change to GitHub. And then we go to Jenkins. It should be trigger a new job. Yeah, as we can see, it's 148. So when we go to the console output, as we can see here, after install some npm packages, and our tests will pass, and after the tests are passing, we will try to deploy all slavers use Ansible. As you can see here, we have several slaves, and then the build is success. And when we go to this one, and when we refresh the page, as you can see, this is canary. As you can see, the page are already updated. So this is for stable version of software, since we only update this page. So yeah, let's go to the second task.
So the second task is to automatically deploy the infrastructure components such as web server, app service, load balancer, and Redis store. Here we use Ansible to deploy these applications. First, let's start.
So we will try to use Ansible to deploy our master server. So we first go into it and try to type Ansible playbook inventory, and basically it will install the first setup, install the Redis server, and try to start the server and do some other things. Yeah, now we are trying to start the flag selector service, and the the alert things and to try to start for wherever first and try to start some other services. And after we finish, we can go to the we can SSH to the master server and try to manually check whether these servers are already start or not. Then we can wait for a little bit.
So here we can see our main repository have already been here. It has already been deployed to our master, and then we can check the status of some services like scaling, selector, or balancer. So here we can see the balancer has already been loaded. Selector and scaling are also here.
Yeah, so it should be finished soon.
So I think it's done. Yeah, it's done.
Yeah. So now we are in the master server, and we try to first check scaling. Yeah, scaling is up, and also try to check the balancer. Yeah, selector is also up, and also the last one is balancer. Yeah, the balancer is up. So actually, we successfully configure our production environment, and it is automatically use Ansible.
So let's go to task 3. Task 3 and task 4 are we are going to deploy a monitoring in each slabs, and it will monitor the status of the operating system, and it will store this performance metrics in Redis, and in master there will be a service, a scaling service that will check the status. It will check every 1 minute the average CPU and the memory load in that 1 minute. So here.
So since it has we need to use two predefined rules. So we will combine task 3 and 4. So our predefined rule is, so the average usage of CPU and memory is larger than 70%. So in 1 minute. So we will try to first send the email, and we will also auto scale a new AWS EC2 instance. We can first check the already existed. EC2 instances, and we refresh it. Yeah, there's a 2. So we'll try to start the strength test. So we'll first check the monitoring is already up, so it will monitor the CPU usage. Currently is 0.05. Yeah. So we will start the strength, and we will manually do it, since we just simulate a real situation when lots of traffic is going to our server. So we will just wait, and this is CPU usage. I think it's going up. Then we can wait it until the average CPU usage in 1 minute should be bigger than 0.7. So even it's already bigger than 0.7, we have to still wait, since we calculated the average in 1 minute. So we have to still wait. So actually, it's bigger than 1. So we think the AWS EC2 instance can be overclock. So we have just wait. It should be happen soon. Yeah, as you can see, we'll try to refresh. Instance. Oh, okay. As you can see now, a new instance is created, and we just try to close our strength test. And in theory, it should create more than 1 instance, since currently our load coverage is still, the average CPU usage is still bigger than 0.7. So our email should be soon. Yeah, currently we can go to this IP address and try to check whether the server is start. When there should be some waiting time before the AWS EC2 instance build. So as I mentioned before, since our load average is above 70% is maybe more than 1 minute, is longer than usual. So we create, actually it will auto scale 2 instances as when we go to the EC2. As you can see, before we have only 2, now we have 4. So if we this is just the IP of the second one. So this is the IP of the first one. We'll try to check whether these 2 is okay or not. So as you can see, our new created AWS instance is already on. So which which means we finish the task 3 and 4. Oh, I forgot. The email is already received. Oh yeah. So yeah, then we will go to the task 7. So actually for feature flag, we already built a GUI page for feature flag. It's already on master server port 8085. So actually we have 2 versions. One is stable version of software, and the another one is canary version of software. So we predefined for our stable version of application, we will be available to feature 1 to 3. However, for canary version of software, it will be available to feature 1 to 5. So as we when we enable turn on feature 1, 3, and 5, we expected our stable version will have 1. Canary version will have 1 and 1, 3, 5, and the stable version will have 1 and 3. So actually, this port 3000 is our load balancer. So which means in 7 which means 70% of traffic will go to the stable version of software, and 30% of traffic will go to canary version of software. As you can see in our code, when the random number is bigger than 0.7 and alert is 0, we will go to port 3001, which is canary version of application. And actually, we also read the IPs from this proxy key which is stored in Redis.
Yeah.
And yeah, when we go to the requirement, we can see the last step is it will stop routing traffic to canary if alert is raised. And if we go back to the this feature selector page, if we manually click the alert and try to set it, if we go back to this load balancer page and we try to refresh, it's always stable. So it means all traffic is go to the stable version of application, and no canary version of application will be reached. So I think this is our work for milestone 3. Thank you.